Okay, hi everyone. So we'll start our new chapter, which is topic 4, differentiation. So for P3 differentiation, it will be something that built on the foundation or like the content that you have learned previously in P1 differentiation. So before I actually move into today's learning outcome, I just want to do a very quick revision together with you for the content that we have learned previously in P1. Okay, so we'll start the lesson by doing some revision on the things that we have learned previously in P1 differentiation. So if you want to do the revision together, then you can take out a sheet of paper, then after that write it together with me. Okay, so when we first started the topic of differentiation, right, we actually started with the concept of limit. So differentiation is like a process where we find out what is the rate of change of one variable with respect to another variable. So one of the very popular application that we use differentiation is to find the gradient of tangent at a certain point to a function, which normally is like a curve. So when we talk about tangent, we normally relate it into a small change of y over small change of x. So meaning when every we want to find out for every increase in one unit for variable x, what is the change in variable y? Okay, so differentiation tells us that it's like when we try to do a limit where we try to approach our small change of x nearer and nearer to 1. So it's like when small change of x approaching to 0 for the function of small change of y over small change of x is actually give us dy dx. Okay, but we do not need to know exactly what is the first principle of differentiation. So what you just remember is that you can recall the uh, example that I gave it to you where we draw a curve. Then what differentiation means is like, for example, I want to find this tangent, right? Okay, and I want to find out what is the gradient, but because of I cannot have these 2 points on the curve itself, so that's why what I try to do is I try to make the changes nearer and nearer to 0. So this is basically what dy dx means. Okay, then after that we learn about like different techniques of differentiation. Okay, so some of the quite simple one, like compared to what you have learned previously in MX. So this is just like a basic knowledge. Okay, so we have, for example, like when y equals to x to the power of n, then your dy dx will be equals to nx, then n minus 1. Then if you have y equals to a constant a, then xn, then you will have dy dx equals to na x n minus 1. Okay, so if you have plus minus, then it will be something like y equals to ax to the power of n plus or minus bx to the power of m. So you will carry out the differentiation by looking at them as like a individual term. So what you will get is basically like n ax n minus 1 plus minus mbx then m minus 1. Okay, so you are looking at them like independently. Then the last one you have learned for the composite function, which you have y equals to the whole function to a certain of degree. So for example, like 2x plus 3, the whole thing in bracket, then to the power of 5. So things like that. So you're going to do your dy dx by following the exactly same thing. So bring your power in front, then after that you can copy the function that you have. So power minus 1, and don't forget you need to differentiate what is inside the bracket. Okay, so these are the 4 techniques that you have learned previously in P1. Then for P3, we are going to go much more advanced than that. Alright, then after techniques, we also learn about how do we use it to find the tangent and also the normal. Okay, so I'm not going to talk about the part where you need to do your substitution for 1 minus y1 equals to mx minus x1. So that's like a straight line equation. So what you have learned is that dy dx is basically equals to your gradient for your tangent when you substitute the x that you want to find lah. Okay, then after that, to find your gradient for normal, then you will try to do negative 1 over your gradient for tangent. Okay, then after that you will continue with the straight line equation process. Okay, so after this, then what you have learned is we learn about the rate of change. Okay, so for example, when we said what dy dx, it actually means that the change of, yeah, the change of y with respect to x. Okay, so for example, with if dy dx equals to 2, so we know that the y is actually increasing 2 unit when your x increase for 1 unit. So we said that, so if we say that dy dx is equals to negative 5, it actually means that y decreases 5 units as every unit increase in your x. So like when x increase 1 unit, then your y will decrease 5 unit. Okay, so that's the idea. And for this part, right, we actually use it in a lot of like application also, where we don't really deal about the variable for x and y only. So we deal with things like dA dt, which we say that the rate of change of area with respect to time, so stuff like that. Okay, so under this part, you also learn the chain rule also. Okay, so I'm just going to write it like in a general form, but yeah, I mean, you can understand what I mean lah. So like, for example, if I have dy dx and I have another variable of u, then I can always put it in a way that dy du multiply with du dx. Okay, so that's the part for rate of change. So because we know that the dy dx, when we talk about the change of y with respect to x, we are actually referring to like a gradient, right? So under this part, we also learn what is that mean by the increasing function. Okay, and also decreasing function. So when we talk about increasing function, it's like when the x increase, then y also increase. So when we talk about the decreasing function, meaning that when your x increase, then your y decrease. So for example, if let's say I have something like this, okay, then definitely you can see that when my x increases, meaning my x is like here, right? So when my x increases, my y also increases. Okay, so meaning the rate of change of y will always be positive. So that's why my dy dx will be greater than 0. Okay, so if it's a decreasing function, then it will be look something like this. So when your x increases, what happened to your y? You can see that the y actually decreases. So in this case, for every decreasing function, then you will have a dy dx lesser than 0. Okay, so it's like, for example, I'm trying to draw the gradient, then you can imagine that you are going to get all the tangent as positive. Or like all the gradient for your tangent is positive. So it's the same thing here. If you are trying to draw a gradient, a tangent, then you find out what is the gradient, then you'll realize that all your gradient should be a negative one. Okay, then the last one, by using the idea for like increasing and decreasing, we actually learn about the stationary point. Okay, so the idea is we know that the gradient of the tangent is actually we can find out by using dy dx. So let's say if you have something like this, where this is the minimum point, and the other one something like this, where this is the maximum point, you can realize that they will have a gradient of 0. Okay, so that's why when we talk about stationary point, we say that dy dx is equal to 0. Okay, but under stationary point, we have two different types. So the first one is the minimum point. So the second one is the maximum point. Okay, so stationary point is just basically mean that dy dx equals to 0. It didn't decide whether it's a minimum or a maximum. So you need to further to do your working and so on to find out whether it's minimum or maximum. So if it's a minimum, then it will look something like this, right? So you can imagine for this part is a decreasing function. So that's why your gradient will be a negative one. Then you reach to a 0, then positive one. So from here, what you can see is when your x increases, your dy dx, meaning your gradient to your tangent actually increases, like from negative to positive, right? So that's why to check whether it's a minimum point or not, your d square y dx square, mean your second derivative must be greater than 0. Okay, so meaning that the rate of change of y with respect to s will keep on increases when your x increases. So that's why it's like another rate of change for your dy dx. Okay, so when we talk about dy dx, we're talking about the rate of change of y with respect to x. So d square y dx square is like the rate of change of dy with respect to the rate of change of with respect to dx. Okay, so we talk about the rate of change of the gradient with respect to the x. So it's the same thing for maximum. So maximum point, you have something like this where it goes from positive to 0 and then to negative. So when x increases, you can see that the dy dx actually decreasing. Okay, so for this one, then you will have d square y dx square. The rate of change actually become a negative. Okay, then for maximum and minimum, we actually use it in the application also, which you want to find out like the maximum area or the maximum volume. So we are not going to talk about for this part lah. Yeah, it's basically some application question. So those are the content that you have learned previously in P1, and you are still going to bring all this knowledge together with you when we start our P3. Okay, so now let's look at today's learning outcome. So you are going to learn how to differentiate products and quotient. So I think no matter you are taking IG or SPM, actually you have learned this in MX as well. So that's why it's going to be a quite simple lesson for you. And I hope that it's going to be a very short one. It's just like a revision for you, I guess. Okay, so yeah, but then for today we are only looking at the product rule, meaning like the UV, and the quotient rule, which is U over V. Okay, and we are not dealing with the differentiation for natural logarithm. Alright, so we'll be doing this after the next lesson. Okay, so let's look at the first concept, the product rule. So when we are using product rule is when we have a function y equals to function of x. So your function of x can be always splitted into two parts, which is u and v. So for example, it will be something like if you have y equals to 2x plus 1, then multiply with 5x minus 3 to the power of 3. So you can see that if you want to expand it, then it will be like pretty complicated. So you can always use binomial and so on lah. So but then to prevent the working, so that's why and we can see that for this function you can split it into two parts, which the first part is like the u and the second part is the v. So that's why we will try to use product rule to help us to solve this kind of questions. Okay, so let's try to go through the derivation part like in a brief way, because you actually didn't learn first principle when you were in P1. So that's why it can be a little bit like difficult for you to understand the derivation part. But what is more important is actually the application after this. Okay, so you can try to imagine, right, if I have y equals to fx and then y is equal to uv. Okay, so you can imagine something like this. If let's say I have y equals to 2 multiplied by 2, then you will get y equals to 4, right? So now you can imagine if there is some small changes happen to 2 and 2, what will happen for your y? So for example, now I do not want to find this anymore. So let's say I want to find 2.221 multiply with like 1.999. So you can see that it's like a small changes happen to the 2 and the 2 here. So what happened? Do you still get y here? So your y previously was 4, right? So after you make some small changes for u and v, are you still getting y? No. So you are sure there is some small changes that happen in y as well. Okay, so that's the idea, but we are trying to put it in a more general way. So if I have a small change in my u and v, it will always create a change for my y variable as well. So we try to write it in this case. Okay, so meaning for every variable there is some small changes. Okay, so now let's try to expand it. So y plus small change of y equals to uv plus u small change of v plus v small change of u plus small change of u small change of v. Okay, so now what is y here? Y is uv, right? So uv plus small change of y equals to uv plus u small change of v plus v small change in u plus small change u small change v. Okay, so you have both side uv and uv, so we can cancel each other. Okay, so this is what we have here. So now we are trying to use the first principle to solve it. So that's why we try to, sorry, you are still having, yeah. So we will try to divide the whole equation here by small change in x. So small change in y over small change in x equals to u small change in v over small change of x plus v over small change of x as well. So same thing. This is u. Okay. Then after that, you remember just now when we recall for the definition of differentiation, right? We talk about the limit. Okay, if you have your small change of x is approaching to 0, meaning your small change of y over small change of x will be equals to dy dx. So we are going to do the same thing. So you imagine that all this small change of x is approaching to 0, what you will get. So this one will become dy dx, and this one will become dv dx, du dx, dv dx. So how about the small change in u? So you can imagine if we say that x is the function of u and v, right? So if the small change of x is equal to is approaching to 0, meaning the small change of u and small change of v will be approaching to 0 as well. So trying to say it like this. Okay, so when small change of x is approaching to 0, so the part where we say the small change of y over small change of x will actually approaching to dy dx. Okay, and then small change of v over small change of x will be approaching to dv then dx lah. So same thing, small change of u over small change of x will be approaching to du dx as well. Then the last one, small change of v. So we have written this, so we don't need to repeat anymore. Okay, so now let's try to change everything that we have here. So dy dx will be equals to u dv dx plus v du dx. Okay, so you can imagine if your small change of x is approaching to 0, the small change of u and v were approaching to 0 as well. So that's why this part will become 0. Okay, and then it's v dv dx. Okay, so 0 times dv dx, then you are getting 0, right? So we left with the last part, which is dy dx equals to u dv dx and then plus v du dx, which is exactly what we have for the formula for the product rule. Okay, so dy dx will be equals to the first original function for u, then you differentiate the second part, then you rewrite the function for second part and you differentiate the first part. Okay, so that's the idea. So now let's try to look at only the two example, because I think this is something that you have learned previously already. It's just like a recap for you. Okay, so number one, find divide dx when y equals to 2x minus 1 square root 4x plus 5. Okay, so same thing, we just try to, you can see that there's two part which you can split it into uv, right? So that's why we can just let u equal to 2x minus 1. Then after that, let the v equals to square root 4x plus 5. Okay, so maybe we can just straight away change it here. So 4x plus 5 to the power of 1 over 2. Okay, so we can try to, I mean, it depends on you whether you want to straight away put it into an equation or you just want to do differentiation first. So you can just start with du dx equals to 2. Then after that, dv dx here will be 1 over 2 to the front. Then after that, for okay, I use the way that 2x, so 4x plus 5, then after that you get negative 1 over 2 and multiply with 4. So from here, 1 over 2 times 4, you are getting 2. Then after that, this will become 1 over, so we straight away, 2 over square root for 4x plus 5. Alright, so now we can try to put everything in the equation. So you have y equals to uv, right? So that's why dy dx will actually equals to u dv dx plus v du dx. Okay, so substitute your u, substitute dv dx, okay, then after that plus your v, and then du dx, which is 2. Alright, then you just continue to solve it out. Okay, so let us try to simplify it. So you get 4x minus 2 over square root 4x plus 5. So you have 2 square root 4x plus 5. Sorry, this is plus. So let's try to make this, simplify them, then put them into a single fraction. So we try to simplify the denominator part. So like 4x minus 2. So we, what is that called? We try to multiply this term with square root 4x plus 5 over square root 4x plus 5. Okay, so you're actually over 4x plus 5 and then plus 2, so you have another 4x plus 5 at the top, then divide by square root 4x plus 5. Okay, so you just try to simplify them. So 4x plus 8x, you get 12x, negative 2 plus 10, then you have plus 8 over square root 4x plus 5. Okay, so that's it for your last answer. So let's try to move on to the next questions. Okay, so let's continue with the second question. Find the x-coordinate of the point on the curve y equals to 2x minus 3 to the power of 2x plus 5 to the power of 3 when the gradient is equals to 0. Okay, so this is just the same thing, but you are just using some knowledge that you have learned previously in P1. So let us start with the differentiation as well. So y equals to 2x minus 3 square x plus 5 cube. Okay, so it's the same thing. So you see, if you do not want to write it in just now that way, then what you can try to do is you can straight away substitute here. But it might get a little bit like, what is that called? Confusing in that sense, because you are trying to put everything together. So just now like uv, you can try to write it out, then you simplify, then only substitute. So now you are doing all the simplification together in the equation. But I mean, if you are confident enough that you don't make any careless mistake in between, that it should be all right also lah. So depends on you. So the idea is, if you don't want to do like that, then you can straight away. So dy dx will be equals to 2x minus 3 square. Then after that, dv dx, right? So you are going to differentiate this part. So we are doing it together here. So x plus 5 square, then multiply with only 1 lah, okay? Then after that, you continue with plus. So your v is x plus 5 cube. Okay, then differentiation for the u part. So you have 2x minus 3 to the power of 2 minus 1, you get 1. Then after that, multiply with 2. Okay, so you can just expand them, simplify it. So you get 3, which you can always write here, then x plus 5 square. Okay, plus 2, then you have 4x plus 5 cube, then 2x minus 3. Alright, so after you have write it in this term, then now what you need to do you need to simplify it by doing factorization. Okay, so you have 3 and 4 here, which you do not have the common factor, so you can continue, but you have 2x minus 3, 2x minus 3. So you can bring out 2x minus 3, then x plus 5 cube, square. Okay, so what you leave inside the bracket will be 3 times 2x minus 3. Alright, then plus 4 and x plus 5. Yeah, I hope you can see what I am trying to do. So the common factor here, so x plus 5 square, and also 2x plus 3, because this is power 2, this is power 1. So that's why only one common here, which is 2x minus 3. So after I take this 2 factor out, for me to get back the first term, I need to times with 3 2x minus 3. Then only when I expand it, I get exactly what I have here. Then the same thing, the second part, I need this term so that when I multiply and expand, I get back the second term. Alright, then I will continue. 2x minus 3, x plus 5 square. So you can do whatever is necessary inside for x plus 20. Okay, so your last answer, you will have 2x minus 3, x plus 5 square, then 10x plus 11. Okay, so this is the simplified answer. So make sure that in your exam, you also need to do the simplification, like instead of like putting your answer like in this case, right? You can definitely see that is clearer when you try to write it in this form. Okay, so this question want you to find out the x coordinate when the gradient is 0. So that's why when gradient equals to 0, it actually means that your dy dx equals to 0. Okay, so what you need to do, then you need to substitute lah. So dy dx equals to 0, meaning that 2x minus 3, x plus 5 square, 10x plus 11 will need to equals to 0. Okay, so how do you solve it? So this one is already in factorized form, right? So it's either this part is 0, or this part is 0, or this part is 0. So you just solve it like 2x minus 3 equals to 0, which gives you x equals to 3 over 2. Okay, then the other possibility is x plus 5 equals to 0. So you have x equals to negative 5. Then the last one, you have 10x plus 11 equals to 0. So your x will be equals to negative 11 over 10. Okay, so all these three number will give you, or will leave your dy dx as 0. Alright, okay, so that's it for the product rule. So let's try to see the second concept, which is the quotient rule. Okay, the quotient rule. So same thing, let us try to start with the derivation part. So since I have explained to you what is that mean by the small change, so I'm not going to repeat it again. So the small change of y then will equals to u plus small change of u over v plus small change of v. Okay, so you know that y is equals to u over v, right? So now what we try to do is we try to move it behind because what we want. So the derivation for the from the first principle is actually we need to put small change of y over small change of x in front. So that's why we try to move the y behind. And instead of writing it as y, we can always write it by substitution u over v. Okay, so now let's try to simplify the fraction here. So how can you actually make your v and u become something that you can try to minus? So meaning this part we need to multiply with v. And the second part here, you will need to multiply with v plus small change in v. Okay, so now let's simplify them. So you can see u times v, so you are going to cancel out each other. So what do you left? You left with v small change of u minus u small change of v. So divide by v plus small change in v. Okay, so now maybe let me just expand this out so you don't need to write so many steps. So v square plus v square root of v. Okay, just expand it. All right, so now let's try to do the same thing. Divide the whole thing by small change of x. Okay, so v dx minus u small change of v over small change of x. Okay, divide by v square plus v small change in v. Okay, I hope that you can understand why the divide by dx only happens in numerator. The idea is since all of this is divide by each other, right? So if let's say I have uh 1 equals to x over y, so it's 1 equals to x divided by y, right? So if I have 1 over u, then I can just, I mean, they are the same term, so I do not need to really do x divided by u divided by y over u. It's just the same thing where I just put them together where x divided by y and divided by u. Okay, so if I were to simplify that, I can always write x over u over y like that. All right, so that's the idea, or it will be the same thing if I do something like this lah. Okay, but since that it's easier for us to solve later, so that's why we are writing it in this term. Okay, so let us continue. So as the small change of x approaching to 0, so small change of y over small change of x will be approaching to 0 as well. And small change of u, small change of x will be approaching to du dx. Same thing for the other one. Oops, sorry. X approaching to dv dx. Okay, so now let's try to substitute. So dy dx equals to v, then du dx minus u dv dx. Okay, divide by v square. All right, and then plus. So what you can realize here is you have a v, then small change in v, right? So you can imagine if let's say the small change in y is approaching to 0 already, so meaning that the small change of v will be approaching to 0 as well. So v multiplied by 0. So we know that v multiplied by 0 gives you 0, so that's why dy dx will actually equals to u du dx minus u dv dx. Okay, then divide by v squared. So this is how the formula for the quotient rule come from. So you can see that we get exactly same thing here. Okay, so same thing like the product rule, we are going to do only 2 examples. Then after that, you are free to continue your exercise. Okay, so let's try to do the first question by doing it step by step. Okay, so actually for this question, you have 2 choices here. So if you do not want to use quotient rule, right, you can always change it into y equals to x squared minus 5 and then 2x plus 1, -1, then you can just use y equals to uv to do that lah. Okay, but I mean, since we are using quotient rule here, so we are just going to practice it once. Okay, so let y equals to u over v. So u equals to x squared minus 5 and v equals to 2x plus 1. So let's try to solve it here first. Du dx gives you 2x, then dv dx gives you 2. Okay, so let's try to put them in the formula. So dy dx equal to v du dx minus u dv dx over v squared. So your v is 2x plus 1, du dx 2x, u x squared minus 5, dv dx is 2. So divide by the whole thing, v squared, so the v is 2x plus 1. Okay, so you need to further simplify them. So you have 4x squared plus 2x minus 2x squared plus 10 over 2x plus 1 squared. Okay, so 2x squared plus 2x plus 5, plus 10, yeah, divide by 2x plus 1 square. So remember, whenever you do differentiation for, especially when you deal with a product rule or quotient rule, right? So if you can, then you can try to like make your answer in a simplified, like factorized form. So 2x squared plus x plus 5. Okay, then you can further check it out whether this term you can try to factorize it or not. So I think this one b squared minus 4ac you are getting lesser than 0, so you actually can't simplify. Okay, so that's for this question. So let us try to move on to the next one. Okay, number 4. So this is another question that you can actually change it into uv form instead of u over v. So that's why actually for a question like this, right, I recommend you to just go for product rule instead of quotient rule, because the simplification part will be much more easier when you compare to quotient rule. Okay, so but yeah, we are just doing this like practice lah. Okay, so y equals to u over v. So let u equals to x plus 2 cubed, and then v equals to square root x minus 1, which we write it in the form of x minus 1, 1 over 2. Okay, so we can start. Du dx equals to 3x plus 2, 2. So since you are multiplied by 1, so I don't continue here. So dv dx, same thing, 1 over 2, x minus 1, then -1 over 2. Okay, so since it's also giving you 1 when you differentiate what's inside, so that's why no need to continue here. Okay, so now maybe for this form, you can write it in an easier way. So 2, then x minus 1. So now we try to substitute inside. So y equals to, dy dx, okay, will be equals to v du dx minus u dx dv dx divided by v square. Okay, so your v du dx u dv dx. Okay, so now how can we simplify? So you can, don't forget your v square. So your v square will be square root x minus 1 square lah. Okay, so how can you simplify? So you can realize that there's another fraction for the numerator part. So you might need to combine them together, then after that bring it to the denominator part. So the front part here, how are you going to combine with this? So you might need to multiply by 2 square root x minus 1 as well. So, okay, I'm writing down the whole step so you can see this slide clearly. So what we are trying to do is we are multiply the whole thing with 2, then x minus 1. So same thing happened here also lah. Okay, and then minus, so I have x plus 2 cubed over 2 x minus 1. Okay, so now we can simplify this, so x minus 1. So let's simplify the top part. Okay, so when you multiply, then 3 multiplied by 2, you get 6. So square root multiply square root, you get x minus 1. Okay, then you can continue with it. So x plus 2 square minus x plus 2 cube. Divide by the whole thing, which is 2. Then x minus 1. Okay, so we don't want to confuse ourselves. So this is divide, right? So we straight away bring it up here. So multiply by 1 over x minus 1. Okay, so now you can try to combine them together. So you can see that for the first part here, there's something that we can try to simplify again, which is x plus 2. So x plus 2 squared, then you left 6x minus 1 minus x plus 2. Okay, so same thing factorization. You are taking out the minimum, the lowest common factor. Lowest common factor. Yeah, like the common factor, which is the lowest degree here lah. So when you multiply, then you get 2, then x minus 1 and x minus 1. Okay, so continue to simplify. Square, so 6x minus 6, 6x minus x, you get 5x, negative 6 minus 2, so negative 8. Okay, so divide by the whole thing here. So you can combine them together. So 2, this is power 1, this is power 1 over 2. So when you plus them together, you get 3 over 2. Okay, so if you want your answer not in index with a fraction form, then you can always change it into square root. Okay, so 2 whole thing here. So this is a square root x minus 1 to the power of 3. Okay, so this is how you get to your answer. Alright, so that's it for today's lesson. I think it's actually quite easy for you because you have learned it previously. It's just like a refresh of memory for you. Okay, so please continue with your exercise and do revision for your test. Alright, thank you.